How does it feel to be part of the biggest dataset ever? What makes your data soul unique to the other data souls around you? How does your data soul integrate with the data constructs nearby? Welcome to Hacking the Universe with Tony Nolan, brought to you by G3N1U5. Throughout time, people have been trying to find a universal constant. They have searched for connections between everything, some way to model everything, to understand, to plan, to explain, not only to survive, but to grow. But they constantly looked without rather than within. The problem has always been trying to find something in reality that explains reality, but nothing has ever been found. But what if we took a different approach? What if we redefined the universe away from the physically defined one to a cognitive one? Or let's even go one step further, a data universe. In a physical universe, we have thoughts, physical things, events, behaviors, relationships, and connections. In the data universe, everything has data, entities are constructs, data equals life, data is both active and passive, everything has cause and effect, everything has patterns, and data is multidimensional. But in the framework that we use to analyze this, we use subject classification, fuzzy logic, constructs of constructs, parent and children hierarchies, and relativity. I will now start to explain each one of these. Classification and indexing systems have been used in libraries throughout our time. They are storehouses of human knowledge. They contain physical observations, cognitive creations, our thoughts and imagination. They are across time, and they are all indexed within the system, which means that they were easily retrievable. We use fuzzy logic in the model because it's more realistic. We live in a fuzzy world, we work in a fuzzy world, we play in a fuzzy world. So why do we build our computer models in a crisp logic when everything around us is fuzzy? An entity can be physical or cognitive, action or event. Entities are made of constructs, which are made of data and metadata. Constructs are complex patterns which are made of simple commonalities. Data and metadata are interchangeable depending on your focus. All constructs are considered equal. Parent and child hierarchies are quasi-fractal. They're in 3D, which makes them repeatable as well as situational. Relativity gives perspective and balance. It allows everything to be modular. We can capture the time and space of any interaction, event or entity, and it also allows us to follow a cause and effect philosophy. Because we can observe and or think about every item or idea in our universe, we can label them, which gives us a framework, measure their cause and effect, place them within a system and hierarchies, and measure the difference based on change and time and space. By transforming the physical universe into a data universe, we have the opportunity to observe entities and phenomena, both physical and mental. We can see where they are similar or dissimilar and what overlaps they have, with everything physical, mental, action or event now mapped as a construct with a cause and effect. We can dissect the universe to see where the different impacts, connections, intradependencies, interdependencies, and how things function in different situations. With redefining life, we can see how data is born, grows, changes, transforms, and dies. By finding problems and questions in the physical world, we can explore them in the data universe to gain answers and insights to be applied back in the physical world. Because it is the data universe, we control the laws of nature and physics, which allows us to play what if to find the best answers and solutions. Peer relativity, a transformation to bring like to like together. Digital fingerprinting hash, a distance-preserving discrete cosine transformation. Language indexing, a way to map languages using phonetics, sentiment, and usage. Role-play game surveys, a new type of survey style. 3D dendromatrix, a 3D matrix for mapping cause and effect. Panocausality, a way to map and explore the data universe. Capstone/cohorts, hierarchical stratification modeling for between population and within population profiling. Chromatica, using colors for mathematical calculations. The outcome of this work so far has been color data processing, optical color processing, fuzzy analog circuits, APIAR and Android app, knowledge nets, message encryption, and data compression. Some of the outcomes we have been experimenting with has been motion tracking in horse riding, horse racing, competitive sports and weather patterns. We've been looking in the educational area for muscle memory training, for yoga training and school educational projects in hybrid computing. We've been looking at gaming in IQ motion puzzles. We've been looking at decryption in message transfer and cryptocurrencies. And we're looking into the computing area to do with autonomous robot programming, A-to-I communications, and high-speed control systems. Thank you very much for watching my video. If you would like some more information, you can email me at tony@g3n1u5 or go to our website www.g3n1u5.com. Thank you.